right, so welcome to Building Janky Programs. I'm Philip Forkner, professor at Pierce College, and with us here is Jasper Newkirk, student at UW Tacoma. What's up? All right, so in class we started with something like this. Let me go ahead and get my screen share going. And we're talking about array lists, and so my idea was to try to motivate why do we have array lists, and so the idea was to implement some of these functions with just primitive arrays, and then show kind of how you manipulate these arrays and whatnot, and then how and so then all of this stuff is kind of implemented in ArrayList, and so we don't have to implement it ourselves. And as a matter of fact, what I'm about to do is probably not the way that you would want to do it. But again, it's just to kind of demonstrate the mechanics of how we play with these arrays. So adding to an array, removing from an array, maybe inserting a value in the middle of an array, and removing a value from the middle of the array. So what we did in class on Tuesday was we did this add one method, and basically all it does is it adds an integer to the end of the integer array. And what we talked about was how an array, what it does whenever we create a new array. So here in the main method, we're creating a new array. It has these values in it. So there's 7 values. And what happens is the compiler sets aside enough space for 7 integers. And then the value of this variable A is actually a memory address, and it points to where this set of memory kind of starts. And then it sets aside enough memory for 7 integers, and then it puts those 7 integers kind of inside of there. So the actual value of A is actually a memory address, and then at each element of the array, there's a sequence of zeros and ones that represent these various integers. So if we want to, for instance, add the number 5 to the end of this array, well, it's only set aside enough memory for 7 integers, but now we want enough memory for 8 integers. Well, we can't just add to the very end, because another program or even our own program might have written something to that location in memory. And so we can't just overwrite it, because we might be messing up some other part of the program, or some other program that's running is using that bit of memory. So what we have to do is, in our add one method, we create a new array that's 1 bigger. So now the computer finds a space in memory that now has enough space to fit 8 integers. So it allocates that memory for now this new array. We copy the old array, all the first 7 digits, into that location in memory. And then finally, at the very end, we just add now that new thing. And so in our main method, we set A equal now to this new array that we've created. And then the old array, the original array that we created, gets garbage collected. And now that chunk of memory is able to be written to again. And now A, the new value of A, points to this new location in memory that now can store 8 integers. Does everything that I just said, does that sound about right? I mean, does that make sense?
Yes, I like your line 15. Instead of using b.length -1, you use a.length.
Right on.
That was neat. Yeah, rest I agree with, right? So A is the address of the first element in the array, and then each consecutive address after that is then, the next thing. And then once we reach the end, then it's new, right? And you've got a whole nother set of memory addresses and values in those addresses. And so when we make a new one, it's in a completely different space now.
Yeah.
I like it.
So and this is the problem with arrays, is that they're kind of fixed in length. And so in order to kind of change the size of the array, we have to actually make a full-on copy. Now for an array of size 7, it's no big deal. You know, whatever, 7 integers, it's not that big of a deal. But let's say it was like a gigabyte long or something. So then we would have to make a new array that's a gigabyte long plus another one for an integer, and we have to copy that full gigabyte to the other new location. So that part is really, really slow. And there's some tricks and stuff that you can do to try to make that faster, which we'll get into later in the term. But yeah, that makes it really slow, as opposed to something like a linked list, which we're going to talk about later as well, where instead of occupying a contiguous chunk of memory, the linked list nodes can exist in all kind of different parts in memory. And so it makes it a lot easier to kind of insert and remove. The problem with with a linked list is that since it's in all kind of different locations in memory, it's a little bit slower for random access. So it's very difficult to like access the middle of that list. Whereas with an array list, it's a contiguous chunk of memory. And since each little element has its own index, you can access the middle of the array very, very quickly. So that's what we did on Tuesday, was this add one. And so I think that what we could try to do now is let's do a remove method. And maybe I should just state why we were doing this. I'll go ahead and just run it real quick, just to kind of recap what we did on Tuesday. But so basically you can see here that whenever we print out the array A on line 22, just system.out.println A, it prints out the memory address of what A is pointing to. So this is the actual value of A. And then on line 23, we use the toString method to actually print out the elements of the array in a nice, pretty way. And you can see that this is the original array that's printed out. Then we add one. And so add one returns a new array, a new location in memory that now has 8 digits in it. And we set A equal to that. So now whenever we print out A, it prints out its memory address, and you can see it's a new memory address. It's a new location in memory that now has 8 integers. And then again, just using the toString method to print it out, and we can see that that 5 has now been added to the end, and it's a brand new array. And the old array, this old memory address, Java garbage collects it. And so now that chunk of memory is available for use for other parts of the program or other programs, that kind of a thing. So let's go ahead and try to do here a remove method. And I think what we're going to do is just do like remove at some index. Okay. Okay. So let's, and I think I'm just doing static methods here. Let's see. So we're going to return now a new array that's going to be one smaller because we removed a particular index, and we'll just call it remove. And we're going to be given the original array, which we can call A, and then we'll have some index that we want to remove at. So I don't know, the 5th index or whatever index. And we should probably be doing some checks for like an empty array or something. But anyway, for now, we'll just keep it simple. Okay, so what are we going to do here? So I think, first of all, we're going to create a new array of size -1, right? Because it's going to be one smaller. So we'll do that. Then we'll copy up to index. So copy the old array up to index, and then we're going to skip index, skip the index, and then copy the rest of the old array. Something like that. Sound about right?
So 2 loops or 1 loop?
I don't know. We could just do 2 loops, keep it simple. Yeah.
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 Okay.
Because otherwise we'd have to have an if statement to check if we were at index. And so we would be running that if statement every single time, even though we don't need to. You know what I mean? Yeah. So we'll just copy up to index, and then we'll just make a new for loop and copy like index +1 or something like that. Right. And that way we don't have any like extra kind of for loops and whatnot. Okay. I don't know. There's probably other ways to do it. I'm sure there is maybe better ways, but okay. So we'll do an integer. I'll just call it B again. It's going to be a new integer array of, I guess, a dot length -1. I think that's right. Okay. And then we'll just do a simple for loop so now we want it to be less than index or less than or equal to index. I think less than index, correct? I think less than index. So if we want to remove, let's say, the third element, that would be index 2, right? Oh, no, wait a minute.
Well, yeah, if you're removing the element at index, you don't want I to be index, right?
Wait a minute. So whenever we remove at index, we're not talking about element, we're talking about element. So remove element with index. Okay, so we want I to be less than index. Okay, I think that's right. And then I plus. Okay, now we're just going to copy the old array into the new array. So B of I is just going to be equal A of I, something like that. Good. Okay, so skip the index and copy the rest of the old array. Well, that's just one for loop. So let's see here. So we're going to say for int. Now I is going to equal index or index +1.
Index +1.
Index +1. Yeah. Okay. Index +1, and then I plus. While I is less than now a dot size a dot length -1. That's going to be the last index of a. I think so. And then I plus. And now we're going to just do the same thing. Say B of I is equal to A of I.
So isn't B dot length A dot length -1?
Yeah, so this should be B of I -1. Right?
Yeah.
Yeah.
Well, no. Yeah.
Wait. Right. Yeah, because B is one smaller, is one less than A. So A, we're going to start at index +1 because we're skipping index, but B is going to be at index -1, or at index, in other words, at index. So since I is starting at index +1, which is what A was, we're kind of indexing A with, right? Then B is going to be at index instead of at index +1.
So I, in this case, in this context, is the index at A.
Yeah. So loop over A. We're going to loop over the rest of A. Yeah.
Yeah.
Okay. Yeah. I think I'm pretty happy with that. All right. And now that we've created B, we're going to go ahead and just return it back to the calling program and then set A equal to that. Cool. All right. So let's give it a shot here. So we're printing out the address of A. We're going to print out A. And now we're going to we're going to let A equal, we're going to remove, let's remove from A, let's do index number 3. So that should be this 1 right here. So that what we should get back is 314,592,5 because we already added this 5. So we're going to remove index 0, 1, 2, 3. Let's remove index 3. And then we'll just do the same thing. We'll print it out to prove, to show, right, that A is now a new array, brand new array that's now 7 elements long. And then we'll just print it out to make sure that we indeed remove that 1. And I think we did it. I think we did it. Now we could probably come up with some ways to break it. No, you're shaking your head.
Why does it end in 0?
Oh, it ends in 0, doesn't it?
Looks like we lost the last 5.
The last 5. Yeah, we lost the last 5.
You're less than, so you don't need to do a.length minus 1.
Okay, bam. There you go. That's what it is. Okay.
If it was
so
less than or equal to, then you would.
then we do it right. Okay. So yeah, I confused myself because we got to be clear here. We're looping over A. We're not looping over B. Yep. So instead of having a -1 here, since we're doing strictly less than, then if the length of A is 8, then we're going to stop at 7, which is where we want to stop. Okay. Okay. So let's try that again. Oh, that's a lot better. That's a lot better. Okay. Is this going to work with an empty array? Let's try it. Nope. Index out of bounds. All right. So we got to be a little bit more careful here, I think. Checking for an empty array. Let's see. So where do we get our error? Should we go ahead and fix this? Maybe we should go ahead and fix this. So on line 27 on the remove, it's an empty array. Yeah. So right there, we're trying to access the 0th element that doesn't exist. So that's not going to work. So I guess what we could do here is, I don't know, maybe make an if statement. Say if it's empty, just return.
So yeah, I would do on remove at the very top. To check for underflow, you would say if a.length equals 0, then return like null or something, right?
Yeah. Okay. Check for underflow. I like that. What does that mean?
It's the opposite of overflow. So
Okay.
instead of reaching, the over the last index, you're reaching before the first index. In this case, we don't have any, right? So
okay. Let's go ahead and give that a testy poo. Oh, we're still getting an index out of bounds. Now on 32. Line 32.
How'd we get there?
Yeah, how did we get there? So returning null is okay.
Yeah, so that's not our problem, right? Because we have 5. We have 5 in there. That's the last thing that was printed.
Mm-hmm.
So when we're removing just one element,
got you,
is when we're having the problem.
Okay, so we're creating a new array of size 0. Can you do that? Can you say new int 0?
I don't know.
Okay.
I mean, obviously we can, right? Because we got past that line. 32 is thrown in there.
Oh, okay. You're right. Okay. So here we start off at 0, and we're going up to less than index, which in this case was, yeah, because I'm trying to call index 3. And index 3 doesn't, I think, right?
Yep.
Okay, so that doesn't work.
So up at the top, you also need to check if index was in bounds.
Yeah. Yeah. Okay. So some issues here that we need to deal with. Okay, so yeah, we got to do some kind of a check there. I don't know if it's worthwhile to do that right now because that's not kind of the point of this, but definitely we can see, right, that trying to deal with these arrays and manipulating them is a bit tricky. And thank you, ArrayList, for taking care of all of this for us. I'm curious what ArrayList would do. I think ArrayList would still give you an index out of bounds if you tried to remove something that wasn't in bounds. I don't think ArrayList checks for that. I think you would just still get an index out of bounds error, I think.
Yeah.
Yeah. So if we wanted to make like an improved array list, we could do that kind of a check and maybe do like a try catch kind of statement or something and try to catch for those errors. But no, yeah, I guess, yeah, just an index out of bounds. That's good enough. Okay, so are we somewhat happy with this? I'll go ahead and populate our array back up here.
Yeah. Is it possible we could do a remove first using the remove method we just made?
So remove the first index. Yeah,
Mhm.
I think so, right? Because then we just call remove with index 0. Yeah. So we could make a remove first. Okay, you want us to do it real quick?
Yeah.
Okay. So remove the first element. So public static. We're still going to return a new array, I believe. So we're going to remove the first. And then here we don't need to have an index. And so we're just going to say return. Oh, do we have to make a copy? I guess we have to make a copy. Okay. So integer array.
Why would we need to make a copy?
Don't we?
Well, a copy's made and removed. And it returns it.
Oh, you're
so
right.
we can return the
Yeah.
call.
You're right. You're totally right. So remove a 0. Bam. And we'll just return that. Happy?
Well, you got to test it, right?
All right. So let's see here. I think I'll just copy this. Okay. I think it worked. The 3 is gone. And bam, we're left with just whatever is left there. All right. How about insert? Okay, let's try insert. All right, so public static, we're going to again return a new array, insert something into an original array. Let's see. So this time we need an index and a value, right? So int index and int n.
Yeah.
Okay. So we're going to insert n at index, something like that. Okay. So now we have to create a new array, one bigger. Okay. Then we're going to copy the old array up to the index. Then insert n at that index, and then copy the rest of the array, of the old array. You look, your eyes are, you're kind of like, all right, I don't know. I think that's it. I think we can do it that way, right? So yeah. Okay, so let's go for it. All right, so let's make our new array. B is going to be equal to a new integer array of a dot length, but +1. We're going to make it 1 bigger. Bam. Okay. Now let's copy the old array. So for int I is equal to 0, I is going to be now less than, and we already talked about this, it's going to be less than or equal to index, I believe. No, less than index, because we don't want to actually copy that one at index because we want to put the new one at that index. Okay. And so they're going to go I plus plus. And so, yeah, we'll just say B of I is equal to A of I. Good. All right. So now we're at index. So we're going to say B of index is equal to N. Good. Okay. And so now, again, we're going to loop through the original array, not through B. Okay. And so this time B is going to be one index ahead of A. Okay. So for int I is equal to index
+1.
No, I think it's index. Because remember A, so let's say, we're gonna insert here at index 3. So we went up to 1, 2, 0, 1, 2, then we stopped, then we inserted our new value, but A is still at index 3. So A is going to start at 3. And then 4, 5, 6 up to the rest of A.
So I guess it would depend on how you do it.
Yeah.
I was thinking, if we have I be the index of B now,
Right,
instead of A, right? So then it would be A at I equals, or no, not that, but
yeah. So I'm going to loop over A. So as far as A is concerned, we're still at index, and we got to copy the rest of that. So, and then I has got to be less than A dot length, and strictly less than, so we don't have to worry about the whatchamacallit, the -1 or whatever. Okay, and so now we're going to say B at I plus 1 is going to be equal to A of I. And this should be fine because B, we created B, it's 1 bigger than A, so we shouldn't get an overflow error as you mentioned. That's it. I think that's it. And then we'll return now B back to the calling program. Okay, let's give it a run. And I'll just copy this stuff again. And so now we want to, what do we call it? Insert? Yeah, insert A, and let's go again, index at index 3, and it will insert, I don't know, the number 13 just to, so it's obvious that, something like that. Okay, let's give it a run. Sweet, and I think it worked. So we copied A up to index. We didn't include index though. Then we inserted the 13 at that index, and now A starts at index, which in this case was 3, right? And then does 4, 5, and it copies the rest of A into that new array. And again, notice that all of these memory addresses are different. So A is we're constantly having to create these new indices and that kind of a thing. And so, yeah, and so we found out about, so the index out of bounds kind of problem, also checking for arrays that are empty. So there's still a lot of things here that we should probably try to fix up or whatnot. But again, it's just an illustration of how ArrayList kind of has all of these methods built into it, and the programmers of Java, they built all of these methods, and you can go look at the source code and see how they did it, and it's much more kind of probably complicated and sophisticated than what we're doing here. But hopefully it illustrates the point about kind of the advantages and disadvantages of arrays. Advantage: really fast random access, really slow inserting and removing, because you have to do all this shifting and copying and everything. I think ArrayList, whenever, so let's say we tried to add one to the end. So instead of increasing the new array by 1, I think they increase it by like 50% or something like that. So like if we started off with 10 elements, and then we wanted to add the 11th, instead of just creating a new array of size 11, it creates it of size 15 or something, or it might even double. I don't know. Do you know?
I think it has varied over the different versions of Java, and I think you can actually set it now. I might be wrong about that, but
Oh, okay, cool.
it
So
depends on your data, right?
yeah. So yeah, it kind of makes sense. If you're going to be doing all this copying and stuff, just go ahead and make, so if we start off with a array of size 10, just make it 20, just double the size. So that way you have some room to play with. And then once you get up to size 20, then double it again to size 40, right? So you're kind of reducing the number of times you have to do all this copy business. But I think inserting is still going to be, maybe inserting, that's pretty fast, I think. Inserting and removing, as long as your array is plenty big enough and you're not having to allocate a new section of memory. If you're just playing with one kind of section of memory, it's pretty fast. Insert shifting and that kind of a thing, I think it's pretty fast. Not as fast
You
as
would
a link.
want, yeah, I was gonna say, yeah.
Not as
Linked
fast as,
list for that, yeah.
yeah. So yeah, I think like you said, it depends on what kind of data you're dealing with. And so yeah, we'll definitely continue conversations about that. But yeah, I think that's pretty much all I wanted to do for today. So I don't know. Do you have anything you want to add?
Um, no, I think this is pretty solid. I think there might have been a way that we could have done insert with the add and remove methods that we had already wrote. That might be fun to do on your own time though.
Yeah. You're probably right. That's interesting, because add and remove. Well, let's see. So add. So you mean insert and remove? I think.
No, add and remove to make insert.
Add and remove to make insert, because add only adds to the end.
Yeah.
Huh.
Yeah,
Interesting.
that's the
Okay.
only problem I could see with that.
Yeah.
Well, actually, I don't know.
Yeah.
I'm sure you could do it if you wanted.
Food
It'd
for
be good,
thought.
but
Food for
yeah.
thought. Yeah, I like the idea of reusing code though. That's pretty cool. All right. Well, I think that is the end of building janky programs. Yeah. Thank you, Jasper,
Thank you.
for stopping by. All right. All right. Those of you out there watching, bye-bye.